Hi, Jeff Russo here with a video to the Gilson salespeople on how to do a Moore Industries product line overview using the demo case and also the net concentrator system in the flow lab behind me. The goal of this video will be to present a sample walkthrough of the Moore Industries product line in about 5 or 10 minutes to a customer so that you can present the whole product line and then take the discussion in the direction that the customer leads you with potential applications or as other situations dictate. Moore Industries has 5 major product families. 1, alarm trips. 2, temperature transmitters. 3, isolators and signal converters. 4, P to I and I2P converters. And 5, data acquisition. For a complete description of the product families, a useful tool is the Interface Solution line card. And you can find that on the web or in the literature files. A review of the alarm trip product family often includes a quick discussion of alarm trip basics. Alarm trips are used to warn of abnormal or unsafe process conditions. And we want to emphasize that our family of alarm trips can accommodate a wide variety of process signals, such as 4 to 20 milliamp loop currents, DC voltages, thermocouples, RTDs, resistance signals, or even AC currents. And our alarm trip family provides between 1 and 4 relay outputs. Those alarm trip outputs can be used for high or low alarming and often can have time delay associated with them for noisy process signals to prevent that relay from chattering. Deadband, also to prevent chattering. And fail-safe action, so that if power should fail to the alarm trip module, the relay contacts always end up in a safe state. If you don't completely understand high-level and low-level fail-safe, consult the alarm trip brochure for a description of that concept. For the microprocessor-based alarm units in the demo case, you can also tell your customers that these units have diagnostic alarm outputs in some cases to warn the user if the functionality of the module itself is in question because of an internal circuitry failure. Also emphasize that many of the alarm trips are available with an analog output option, which can reproduce all or a portion of the input signal and send a 4 to 20 milliamp current or a voltage signal over to a control system for monitoring, so that you could have a signal come into the alarm trip unit for a safety function, but then also be sent over to the control system for monitoring purposes. So specifically in the demo case, you'll see the SPA2 and the STA alarm trips. These are microprocessor-based units, which means they're extremely stable, and we actually publish 1-year, 3-year, and 5-year drift data on our units. And using that data, customers can lengthen the amount of time between regularly scheduled calibrations of the units, and this is a great time saver for the maintenance department. You could point out that we have a large display on the front of each alarm trip here in the demo case, displaying process variables and engineering unit labels, and this eliminates the need for a separate indicator in the control panel. All of our alarm trips provide EMI and RFI protection at 10 volts per meter field strength, and most are available optionally with 30 volts per meter field strength. What this means is that you can install these alarm trip modules directly in MCC or motor control center buckets with contactors right next to them, and the switching on and off of that contactor won't cause a false trip of the alarm module because of the electromagnetic interference. You can also use a walkie-talkie in the vicinity of the alarm trip, and you won't scramble the circuitry or cause a false trip. Again, it's peace of mind, and it gives you more options as to where you can put these devices in the plant. The optional analog output that we talked about earlier eliminates the need for an isolator or a transmitter to take that signal and send it someplace else. So if the average cost of an isolator or a signal converter is between $250 and $300, you've basically saved the customer that money by providing the $90 analog output option on the alarm trip unit. Many of the alarm trip units are also available in Class 1 Division 2 or with Class 1 Division 2 approvals as non-incentive for hazardous area installation. And this is a big benefit in field-mounted control panels in chemical plants and refineries and other plants with hazardous environments, because this allows you to locate the alarm trip module closer to the signal source and reduce the length of wire coming from the signal source over to the alarm trip unit. Less likely to be affected by noise and issues of that sort. The specification for temperature on all of our alarm trip units, as with most of our stuff, is minus 40 degrees Fahrenheit to plus 185. And that will suffice in just about any control panel out there. Again, you can mount these out in the field in an unheated enclosure or an uncooled enclosure in the case of an environment that's going to get cold in the wintertime, or for example, on the burner deck of a power plant where the temperature can routinely get up to 130, 140, 150 degrees. You don't need to worry about its effect on the reliability of the alarm trip or any drift on the input circuit. When we specify our input accuracy, that's over that entire temperature range. Another feature to emphasize is that on the microprocessor-based units, we have linearization available for nonlinear signal inputs. So if your customer has a spherical tank and they want to bring in a level signal, but alarm on volume in that tank, you can linearize the input and then set your trip points based on volume. Going back to the analog output, now you could reproduce that analog output signal to the control system as volume and not raw level. And that's a big help too. We also give you the capability for sensor trimming on temperature inputs. So you can stick a thermocouple or an RTD in a temperature standard bath used in the plant for temperature system calibration and actually adjust the input of the alarm trip to match that plant standard. So even though our front end on all these devices is extremely accurate, you can always tune it or trim it to match another standard in the plant that's agreed upon. In particular, I like to emphasize the STA to chemical and refining accounts, because the STA, as you know, is a safety alarm trip designed from the get-go with SIL approvals in mind. And TUV has certified the STA with a SIL 2 approval in a simplex configuration, that is, just one module all by itself. If you use the STA in a redundant configuration using either 1 out of 2 or 2 out of 3 voting, then the rating on that installation will support SIL 3. Now, as you know, the SIL rating of the loop is the sum total of everything else in that loop. So that doesn't necessarily guarantee that the entire loop itself is SIL 2 or SIL 3, but the STA will support other devices in that loop that would allow it to be SIL 2 or SIL 3. So now moving over to isolators and converters, what you want to emphasize to your customers on isolators and converters are the 5 or 6 different applications that isolators and converters are used for. The first is pretty obvious. It's isolation, and that is to cure a ground loop. Where you have more than one signal ground in an analog current loop, the isolator breaks the loop in the middle and sets up 2 independent loops, each with equal signal values, but each of those loops has only one ground. Again, if you don't completely understand the concept of a ground loop and why it affects signals, please refer to our isolators and ground loops brochure in the literature file. The second application you want to mention is signal splitting, and this is becoming more popular with gas companies who share transmitters for measurement purposes and control purposes. Often the compressor automation group will want to read a pipeline pressure from a control standpoint, but then the measurement group also wants that transmitter's signal because that signal is also needed by the measurement system. But if somebody's working on the measurement system, you don't want to disrupt the control system, or vice versa. So that's where a signal splitter comes in. A signal splitter takes that transmitter's input and sends isolated copies to the measurement system and the control system. And each can be worked on independently of the other without disrupting the signal values. The third application that we cover with our isolators and converters is just straight conversion. Often in power plants and other older industrial environments, there's legacy equipment in there that might give -10 to +10 volts DC outputs, or 1 to 5 volt DC outputs, and you want to convert that into 4 to 20 milliamp standard analog signals. Because what this does is it lowers the cost of getting that information into the control system, because if everything coming into the control system is 4 to 20 milliamps, the input cards are cheaper and usually, or maybe, higher density. So by taking this mixed bag of different signals and converting them all over to 4 to 20, you spend money on the converter, but you actually save money on the control system input card. More Industries has the ability to convert any process signal, voltage, current, thermocouple, RTD, resistance, over to a 4 to 20 milliamp analog signal. And they can do specials, minimum quantity is 1 piece, and deliveries usually are pretty good. The fourth application that you solve with isolators and converters is bucking power supplies. And bucking power supplies occur when both a field transmitter and the control system receiving that signal both try to excite the current loop with their own 24 volt supplies and drive current into each other. They both try to act as current sources. When you hook 2 current sources up together, we say the power supplies buck each other. So what an isolator does is it splits that loop in 2 and allows each to source the current in each half of the installation, and the output current is always equal to the input current. That is also covered in the isolators and ground loops and causes and cures brochure. Another application that isolators and converters solve is overloaded loops. Multiple devices in a 4 to 20 milliamp loop can drop more voltage than the power supply makes available. For example, if you put 3 or 4 loop indicators in a current loop and a pressure transmitter, you might run the voltage drop across all those devices up close to or in excess of the 24 volt supply of the loop. And so what the isolator does is it allows you to take some of those devices off of that primary loop and set up a secondary loop whose output is driven by that isolator. A lot of the isolator and converter products are best demonstrated with the use of a whiteboard and a marker, because a lot of you have to explain how the loop is broken and how everything is wired. So don't be afraid to get out a pen and start drawing. As far as the feature set on the isolators and converters that you want to emphasize, we have both DIN rail mount and field mount packages available, and we have analog and microprocessor based units in each of those styles. Most, if not all, with temperature specifications of -40 to +185 F. You'll see that again and again and again in the Moore line. In some cases, we have Class 1 Division 2 approved models available. And in the case of microprocessor-based units, linearization and sensor trimming available on the inputs that give the same benefit I mentioned on the alarm trips. They allow you to calibrate the input to match a signal standard in the plant. Talking about isolators and converters might be a good time to introduce the HIM module. Now, the HIM module is a module that is designed to allow customers to get more value from a HART transmitter loop by extracting extra information that's available in that loop that might not otherwise be used. Specifically, a HART loop has often up to 4 variables of data encoded in the digital data stream coming from the HART protocol transmitter, but an analog input card on a control system is only capable of looking at the DC analog current, or as we say, the primary variable in the loop. So what the HIM does is it wires across the loop and looks at that digital communication and extracts the secondary variable, the tertiary variable, and the 4th variable from that device. And it does it all without additional wiring, because you can locate the HIM module back in the control cabinet next to the control system. So you still only have 2 wires going to the field. Applications for this type of device are valve positioners. If a customer is using a HART digital valve positioner, a module such as the HIM allows you to extract the true valve position feedback signal in that HART data stream, so that the customer not only knows what the analog signal telling the valve where to go is, but the control system also now knows where the valve actually is, because the true valve position is in that digital data stream. The HIM sees it and sends that value out one of the analog outputs over to the control system. Mass flow meters will have temperature and density information in their data stream. Again, the HIM can grab that information and send it out the analog outputs to the controller. Or any other HART transmitter used in a critical application is a good candidate for an HIM, because a lot of those smart transmitters have diagnostic fault information. For example, if a pressure transmitter's diaphragm ruptures, there's a HART digital fault bit that the transmitter will set, but you wouldn't know it unless you're hooked up to the loop with your HART handheld communicator. Or if you've got an HIM on that loop, that's essentially what you have. And as soon as that HART fault bit gets set by the transmitter, the HIM will detect it and notify the control system. So let's talk about the features in particular of the HIM. Specifically, you can see that the HIM has a large process display on the front of the unit. It's a 5-digit LCD process display. It can be programmed for engineering unit display as well. And the HIM has up to 3 analog outputs. And this is a big competitive advantage over other units with similar functionality. We offer alarm relays for process alarming or self-diagnostics of the HIM itself, so that you can differentiate between a process alarm and an HIM failure. Another important feature to emphasize about the HIM is that it can operate in primary or secondary master modes, or what's called a burst mode. Primary and secondary modes are pole response. In other words, the HIM sends out a message to the heart transmitter, let's say in this case a pressure transmitter, and asks it for its information. In the case where the HIM is in the loop with the pressure transmitter and there's nothing else in the loop, the HIM is the only master in that loop. In that case, it's a primary master. But there may be a case where there's also a control system in that loop, and that control system may also be sending messages to the transmitter asking it for heart digital data information. In that case, the HIM should be switched into secondary master mode so that it does not conflict with the control system's requests for information. The HIM can also be put into a burst mode, in which case it initiates no communication whatsoever and goes into a listen-only mode, in which case it just sits there and reads the data coming past it, and it's completely passive. And in this case, it won't conflict with multiple masters on the loop. That's a competitive feature that we have over other similar units in the field in terms of our flexibility in operating in those different modes. And anybody who's tried to use one of these in the field might be familiar with the communication conflicts between multiple heart devices in a loop. We are PC programmable. So the HIM comes with a free piece of software and a cable, and you set it up with your PC using a software package that's got the look and the feel of the other Moore Industries software packages, everything on one screen. Compared with the Rosemount Tri-Loop, where you have to go in and configure it with a Heart handheld communicator over the current loop. And we know that Heart handheld communicator is only this big, the display is only this big, and it only has a few lines on the display, and the menu structure is a lot more cumbersome than that of a PC program. Our software and cable is free of charge. We also offer the HIM in a Class 1 Division 2 configuration, giving the user more flexibility in where to mount it, and this is particularly important in the chemical and the gas industries. The HIM has our very popular -40 to +185 degree temperature specification. Again, your customer shouldn't be afraid to put this in a cabinet out in the elements in an unheated and uncooled enclosure. We also have an application note published by Fisher concerning the use of our HIM with a Fisher digital valve positioner. Fisher is a very popular manufacturer of control valves and digital positioners, and they have an application note covering the implementation of a Moore Industries HIM with their positioner and all the configuration codes necessary to make the two work. They wouldn't publish something like that unless there was a big demand for it in the field and they knew that our device did a good job. So that's not quite a glowing endorsement from Fisher, but as good a one as we're going to get. Moving over to the next product family, temperature transmitters. What you want to emphasize to your customers about temperature transmitters is that Moore Industries has a complete line of temperature transmitters that range in terms of price, performance, and configuration interface. For example, we have temperature transmitters in both DIN rail mount styles for high density installations and hockey puck styles for field mount. And in some cases, the enclosures are big, like this TDZ right here. And in some cases, those enclosures are small, like this one here, that can sit atop a thermocouple or an RTD. You can choose between loop power and line power, and all of our temperature transmitters have that same minus 40 to plus 185 degree temperature specification, again giving you more latitude in where you can put these things. Our most popular temperature transmitter is the TRY here in the demo case. It's 1 inch wide and mounts on a DIN rail. And it can accept any thermocouple, any RTD, a millivolt signal, or a straight resistance signal. So you can bring a wide variety of signals into it, and it's loop powered and gives you a 4 to 20 milliamp output. It comes with a free piece of software and a programming cable and can be set up in a matter of minutes with a laptop. One of the issues that you're going to have to deal with in presenting the temperature transmitter product line to your customers is the objection, we don't use temperature transmitters, we just wire our thermocouples and RTDs back to our controllers, back to our control system, back to our PLC, back to our DCS. Why should your customer use a temperature transmitter instead of direct wiring? The reasons I'm about to give you are detailed in another More Industries brochure on temperature transmitters, which you can find on the terminal server or in the literature file. But let's go through those reasons. In the case of our high accuracy temperature transmitters, many times the temperature transmitter is more accurate than the PLC input card. So let's go through those reasons why to use temperature transmitters instead of direct wiring. With a temperature transmitter, often we can improve accuracy greatly. And this is because for a particular temperature sensor over a typical or given temperature input range, the transmitter can be calibrated for that particular range, as opposed to a control system input card which is calibrated over the entire range of the sensor. To give you an example, let's assume we're measuring a temperature with a span of 0 to 300 degrees Fahrenheit with a J-type thermocouple. We can calibrate the transmitter for 0 to 300 degrees Fahrenheit and concentrate all 18 bits of our input accuracy of that temperature transmitter in that 0 to 300 degree F span. But using that control system input card, that 18-bit resolution is spread out over the entire range of that J-type thermocouple input, which is something like 0 to 1200 degrees Fahrenheit. So you can see right off the bat, we achieve a 4-to-1 improvement in resolution of that temperature measurement by using the transmitter. The second reason is that PLC and DCS analog input cards are often much more expensive on a per-channel basis than temperature transmitters, particularly when you have mixed temperature sensor types, mixtures of different types of thermocouples or thermocouples and RTDs. You convert them all over to 4 to 20. That's the highest volume, least expensive inputs available on most control systems. A third reason might be RFI and EMI immunity. By taking the low-level signal coming from the temperature sensor and immediately converting it over to 4 to 20 and sending the analog signal back to the control system with a live 0, you eliminate a lot of the noise issues from RFI and EMI sources. Temperature transmitters, in particular the TRY, also give you sensor diagnostics and programmable failure modes. If this temperature sensor is part of a loop that shuts down a reactor on high temperature, you don't necessarily want to shut that reactor down if the thermocouple burns out. So by using a temperature transmitter, you have full control over the failure modes that the loop will assume should that temperature sensor itself fail, that you might not have with your control system. You could send the temperature reading high, low, or hold at a particular value. Another reason to use a temperature transmitter is that analog signals are easier to share with multiple receiving devices. Back to my example of a temperature transmitter being used for both a measurement system and a control system. If you're going to split that signal, it's easier to do with an analog signal splitter rather than trying to share the thermocouple millivoltage or the RTD signal between those two systems. Another benefit of using a temperature transmitter is in applications where lightning might be present. The temperature transmitter acts as a glorified fuse in front of the control system, so that a shot of lightning nearby might destroy the $200 or $300 temperature transmitter, not the $1,600 input card to the control system, and possibly take that could possibly take other signals along with it and do much more damage. The final reason to use a temperature transmitter is that, in general, temperature transmitters are much easier to calibrate than a temperature input on a control system. Our temperature transmitters employ microprocessor-based calibration and trimming that can be done with a laptop computer and our free software and a cable and a temperature bath. To do that same function on a PLC or a DCS often involves getting onto the card and making adjustments, or going into the PLC program itself and calibrating or adjusting the calibration coefficients on the card. Typically, those devices are not designed for easy interface to do something like that, but the temperature transmitters are. So there's 7 reasons that you can give your customer as to why temperature transmitters might be preferable over direct wiring. The next product family that we want to talk about are I2P and P2I converters, converting pressure to current and current to pressure. A couple of things to emphasize here to your customers. First is the wide variety of inputs and of outputs available on this product family. Not only 3 to 15 psi, but 3 to 27 psi, 6 to 30, and just about anything else. Moore Industries does specials all the time. Minimum quantity is usually 1 piece. We have models available for both field mounting and control panel mounting, as I have here in the demo case with the IPT2. The nice thing about the Moore Industries I2Ps is that they are position insensitive, so they can be mounted vertically, like I have them here, or I could take the DIN rail and mount it vertically on the side wall of a control cabinet and have the I2P converters sitting in there stacked sideways. And that would recover space that often goes unused in control panels and save real estate there. For DIN rail mounting, we also have units like the one shown here in the demo case with racks that employ a common air header and common piping to each of the I2P modules, so that plumbing is greatly simplified, with self-sealing pneumatic connections here to prevent lost air from the. And these units are available in 5, 10, or 15 position. For field mount units, which we don't have here in the demo case, we have units, like we said, that are available for hazardous area installation, and in particular for customers in the natural gas industry who often use natural gas to drive their valve actuators instead of compressed air. Our IPX2 I2P converter is available with a special NG option, which allows the unit to retain its FM approval for hazardous locations even when used with natural gas as the supply gas. Moving on to the next product family of data acquisition equipment, we have the net concentrator system here in the Flow Lab. And the net concentrator system is a tool to reduce wiring costs. It moves signals between locations using either a single pair of wires or fiber optics or Ethernet cable or spread spectrum radios. And it is available in both peer-to-peer and peer-to-host configurations. Peer-to-peer configuration would be a system of modules bringing data in and sending them someplace else to a similar system of modules where the signals are reproduced at the other end. So the communication is between Moore Industries net concentrator systems and nothing else. A peer-to-host configuration would involve a control system like we have here in the Flow Lab, where I'm bringing in my signals here through analog and temperature input modules, and through Modbus protocol, either over twisted copper wire or a piece of Ethernet cable, I'm reading those signals with a controller, with a Modbus driver. In this case, the Moore Industries net concentrator system acts as remote I/O for the control system. Most modern control systems have no trouble reading Modbus data, and that's the protocol that we've settled on here. So you can see the net concentrator has wide application in industrial control for remote I/O. And again, because our temperature specification is -40 to 185 degrees Fahrenheit on the modules, you can put them just about anywhere you can put a control enclosure. Modules are available for a wide variety of inputs: milliamp DC signals, voltage signals, thermocouples, RTDs, resistance signals, discrete inputs, discrete outputs, are all available usually in 4-channel modules that you see here. All of our signals are isolated: input from output, and input to ground and output to ground on a channel by channel basis. So you have complete isolation on the I/O, and it's extremely high accuracy. All of our input modules employ 20-bit A to D converters, so you won't lose any accuracy bringing anything into a control system, and often you'll improve your accuracy because of the high accuracy front end on the module and then the digital communication over to the host. So that's a quick overview of the Moore Industries product family. And if you have any questions, you can see me or any of the other salesmen at any time. And good luck. Good selling.